Okay, let's get started. This is actually a fairly good turnout. My 8 o'clock class this morning, I had 50% of the class gone, but that was only missing 2 people, so. It's an 8 o'clock engineering class. We started out the semester with 12 to 15 people in the class, and before the first day of class, it dropped down to about 6, and I've lost a couple to attrition during the semester, so I'm down to 4 people in the class. So I come in at 8 o'clock in the morning just for 4 people. And today there's only 2 showed up. So. A couple things we want to do today. There'll be time to work on project today. Give you some time to work on it. The project is due a week from today, so it's maybe a good time to work on some of that. I have some stuff in Blackboard for you to pick up on and work with after we get done with the first section. The first thing I want to do is, when I got the grades back for the last homework, my grader's first comment was, people aren't getting it. So what I'd like to do is go back through that homework, work through those problems, and try to give you an idea of what they should look like so that we get another chance to take a look at them. And I'll try to do this if I see homeworks that are having particular problems. I'll try to come, if I can get time, try to go back through them like this and see what we can do with it. So this was homework number 7. This was problems 1248 and 1261. So if I'd have been thinking, I probably should have brought your homeworks back with me today, but I wasn't thinking that far ahead. So we'll have to wait until Monday to get them back. But we'll just go ahead and work through these and see how it looks. So 1248. For some of the questions I had, these were both probably about the same level of kind of problem. And in 1248, what they give us, they said we got a Time magazine reported in 1994 survey of 507 randomly selected adult American Catholics. 59% answered yes to the question, do you believe or do you favor allowing women to be priests? Then it gives us a reference to it so we can know exactly where to look for this. It starts out saying, set up the null and alternative hypothesis for the deciding whether more than half of American Catholics favor allowing women to be priests. Now, the first thing is, I shouldn't need anything in that first paragraph to answer Part A. Part A tells me how to set up my hypothesis. The hypothesis comes from this statement. It has absolutely nothing to do with the sample. So if you find yourself taking values from the sample, this is a common mistake, using that 0.59 in the hypothesis. You shouldn't be doing that. Okay? So our hypothesis in this case we have a null hypothesis. This is a proportion condition. This is the section we're working on. We should have P is equal to our alternative. Should be the same P. And we should have values in the null and alternative that are identically the same. That's another key that you should be looking for. Occasionally people will take and put something like 1/2 here, 0.59 there, or something like that. These two values have to be exactly the same value. Okay? So when we read the statement, it's asking for a majority. So if a majority agree with this statement, or a majority are in favor of allowing women to be priests. So our null is going to be that P is equal to 1/2. 1/2 is the dividing line between a non-majority and having a majority that are in favor. The alternative has to have identically the same P0 in it. In this case, the statement is that a majority is in favor. That means I'm looking for a greater than 1/2 condition. And it's usually best if when you do this, you also write down exactly what that P means. In this case, P is the proportion of those who are in favor of allowing women to be priests. Okay? Questions on that? Okay, so our hypotheses are statements about the population. We should never see ourselves taking a value from the sample and using it. Another thing that oftentimes helps is if you take these hypotheses and think about what could happen as you apply the test of this. The results I can have is that the proportion of the population is greater than 1/2, or that the proportion is not greater than 1/2. And convince yourself that the two possible outcomes make sense with respect to the question being asked. So if I had put a 0.59 in here, the two possible outcomes could be that either it's greater than 0.59 or that it's equal to 0.59. In both cases, I have a majority. And that doesn't make sense in the context of the original question being asked. So try to take the hypothesis that you got and go back and take a look at what kind of results you can come up with and see if they make sense in terms of the question being asked. Part B says what conditions are necessary for using a z-statistic. Here you should write out the normal conditions. And the biggest thing here was looking at NP0 and N1 minus P0. So this is 507 times 1/2 in both cases. In either case, that number is obviously greater than or equal to 10. So we have plenty of data here to say that we can work with our procedure. Part C says to compute the test statistic. That's step 3 of our hypothesis test. We have Z is equal to that formula. We get this by plugging our appropriate pieces into our template. Plugging the numbers in, P hat should be what? What's P hat in this problem? P hat is 0.59. This is P0, so it's minus 0.5. We want to make sure that we're using the same value from this null value down here in this calculation. So we have 0.5, 1 minus 0.5 over 507. It comes out to 4.05. Okay? Now, if you put the 0.59 in here, you'll come up with something near 0.05 because they're fairly close to each other. But the correct value down here is to use 0.5 rather than 0.59 because this is the standard error based on the null hypothesis. So we want to make sure that we use this condition in calculating this standard error. So that's why we're using this P0. In this case, it makes very little difference in the actual value of the z-statistic. But there are a lot of cases where if this estimate here is very far away from this 0.5, that will change drastically the size of this standard error. So you want to make sure that you use P0 in this denominator standard error. D says calculate the p-value for the test. So we're getting to step 4. So in step 4, the p-value in this case, we've got a normal distribution, 4.05, 0 here, this is 3, 4 is around here. So it's about this point right here that we're looking at. We have a greater than condition. So this greater than is pointing to the right. That means I need right tail